Hello and welcome to Preparing a GHG Emission Baseline Projection, the third and final webinar in the series, Developing Financeable NAMAs. My name is Melissa Harris and I'm a project manager with the Climate Change and Energy team at the International Institute for Sustainable Development. I will be moderating the session today and we have a distinguished group of presenters. Seton Stiebert is an associate with IISD and Marie-Claude Bourget is a project manager with Eco Resources. This will be a 1-hour webinar. The first half of the webinar will be presentations, followed by 20 to 25 minutes for questions and answers. Before I hand things over to Seton, our first speaker, I want to provide a few administrative tips. We hope you will interact with us in this webinar. If you have any questions, they can be typed into the questions section near the bottom of your console at any time during the webinar. Be sure to click on the plus button next to the word questions in order to expand the questions pane. Another way you can interact with us is through polls. Presenters may launch a poll during their presentations. These are useful for gathering webinar participants' input and learning more about you and your needs surrounding NAMAs. As a warm-up, I'm going to launch a poll now. Please select the region from where you are accessing this webinar. I'll give everyone a few seconds to make your selection and then show you the results. The results show that we have 14% from Africa, 31% from Asia and Oceania, 34% from Europe, 10% from Latin America and the Caribbean, and 10% from North America. So it looks like we have strong representation from Europe and Asia and Oceania. I will now launch another poll. Please let us know the sector you represent. So as you can see, 24% from government, 53% from private sector, 24% from civil society, and 0% from academia. So it looks like we have an overwhelming majority from the private sector, which is always interesting to see. So our first speaker today is Seton Stiebert, an associate with IISD. Seton is an environmental engineer with over 10 years of experience developing greenhouse gas emission inventories and conducting mitigation assessments. His experience includes investigating a broad range of low-carbon goods and services, as well as management tools, including emissions trading, environmental charges, fiscal incentives, and regulatory instruments for all sectors of the economy. He has contributed to numerous national communications on climate change for Caribbean countries and helped to develop an emissions baseline for Kenya's National Action Plan. Seton, can I turn it over to you?
Yes, thank you, Melissa. I would like to welcome all the participants to the webinar today. If you've been following our previous NAMA series webinars, this webinar deals specifically with one step in the NAMA Deep Screen methodology. That was presented in the last seminar, and that was, as you see highlighted in yellow, the step 2, developing the reference case. What I'm presenting today is a condensed and simplified version of our online course. Preparing a greenhouse gas emissions baseline projection. You can also go to our website and enroll in this online course until Friday, July 19th, and that way you can complete the course at your own pace. It is likely that our audience today has diverse backgrounds and a very broad range of knowledge, so I've tried in the presentation to go over some basic concepts, but also provide some additional insights into the challenges of developing emission baseline projections. So the first question is, why do we need emission baseline projections? And so we have to think that the main purpose of developing a baseline emissions projection is to provide a business as usual or a reference scenario against which mitigation policies and measures can be evaluated. So we want the baseline emissions projection to be something plausible and a consistent description of how a country could be expected to evolve in the future, in the absence of new policies or regulations that are directed at greenhouse gas emission reductions. So emission baseline projections can also help identify potential nationally appropriate mitigation actions that reduce emissions and contribute also to building capacity to select, design, and implement these actions. In addition, understanding the future trends in greenhouse gas emissions is important, not only for developing domestic policy, but also for informing a country's position in international negotiations. So how can we go about developing an emissions baseline projection? Currently there's some guidance from a number of organizations, including the UNFCCC and the International Panel on Climate Change, on how to develop baseline emission projections. But this is particularly geared towards Annex 1 countries that have substantial resources. And while we can apply this guidance for non-Annex 1 countries, there are also new guidelines that are emerging still. Defining a reasonable baseline projection for greenhouse gas emissions is a critical element in the assessment of NAMAs, as the incremental costs and benefits of these actions depends on how the baseline is defined. So that the challenge is, as the future is inherently unpredictable, and it depends on many, many different factors. So we have changes in energy prices, changes in population and demographics, we have economic growth that could be different, we have adoption of new low-carbon technologies and practices, we have the turnover of capital stock, as well as whenever we implement existing policies that are successful and are reducing emissions. So all of these factors combined make defining a baseline difficult. It also can be somewhat controversial because we have, particularly in developing countries, limited data that's available to help us, and also that past trends in performance aren't a good indicator of what's going to happen in the future. So an emission baseline projection should not simply be an extrapolation of these historic trends, but rather we need to incorporate the judgment of the likely evolution of the economy. We're particularly concerned about how domestic fossil fuel consumption and production develops, as well as there's all this accounting of carbon stocks and other sources and sinks of greenhouse gas emissions. This accounting needs to take into consideration the influence of new technologies coming on the market, so renewables, our high efficiency appliances and vehicles, as well as any practices that we can expect that are going to be adopted and reduce greenhouse gas emissions. Ideally, we would have multiple baselines, or we would conduct a sensitivity analysis to reflect uncertainties of how a country's economic and social environment is going to change. However, it can be very difficult to select a single representation of the future. So what we do is often there's alternate scenarios that we select, and we reflect different levels of things like economic growth or different assumptions in how the price of energy might change in the future, the cost of a barrel of oil, for example. However, resources are almost always limited in these cases and these type of projects, and to keep the assessment manageable, often we're only developing a single baseline or defining a single baseline. So also when we're considering a baseline, we need to think about the lifetime and capital stock turnover of different end uses. So we see a figure here on this slide of different types of stock turnover and their lifetimes. For example, we have the electricity sector where fossil fuel plants can have lifetimes in the range of 25 to 40 years. So emissions from these plants are likely to be locked in for many years, and if we tried to prematurely close these plants, we would cause all kinds of adverse financial impacts. The same thing in the commercial and residential building construction. We have stock that may not turn over for another 50 years into the future. Because of this, projections should be long enough to reflect the economic lifetime and the potential for this stock turnover and for new technologies to come on board. What we see in practice, though, is that because of uncertainties in future development, the focus has been on nearer-term assessments in the range of 20 years that are based on national planning and sectoral assessments that are typical for, especially for developing countries. So I would like to conduct a quick poll to see how familiar participants are today with emission baseline projections from their own country. So essentially what we see is that the majority, just over the majority, have seen emission baseline projections for their country, while there's still a considerable margin that have not. So I'm going to move to the next slide. I'm going to walk through now a simple example to illustrate the key goals and steps to developing a baseline emissions projection. In the first step, we need to consider how greenhouse gas emissions have changed in the historic period. So we can see a black line in this figure that illustrates the total national greenhouse gas emissions for a fictitious country between the years 2000 and 2010. And we can see emissions are being measured in megatons of CO2 equivalent on the horizontal axis. And essentially we show emissions rising from something like 42 megatons of CO2 to 55 megatons of CO2 over the 10-year historic period. Now these emissions include all relevant sectors of the economy. Now there are many different methods and models that we can use to develop a baseline emissions projection. The very simplest method would be to base emissions on what's happened historically, so historic trends. But this isn't a really good estimate, as there are likely to be many changes going on in the economy, as well as in demographics and technologies. Another way would be to conduct a sort of bottom-up estimate of the likely changes in demand for different energy and services that generate emissions, and look at the changes in emission intensity or energy efficiency. But while doing that, we don't want to think about including new policies to address climate change. We could also incorporate in these projections sort of any national projections we have of demographics as well as economic growth, so they can be included in the emissions projection. There are also general equilibrium economic models that we can use to generate projections of labor, capital, and resource use to estimate the productions of goods and services and their related emissions. So in this example, we can see emissions are increasing from their level in 2010 of 55 megatons all the way to 92 megatons in 2030. And this black line from 2010 is essentially the business as usual or counterfactual case that we would then use to assess any nationally appropriate mitigation actions. Now many countries, particularly Annex I countries, have identified targets for future emission reductions. So in this example, we imagine that a country has set a target to reduce emissions in 2030 to the same level as they were in the year 2000. And also we have another midterm target to reach half of these emission reductions by the year 2020. Now that we have a baseline emissions projection, we can then consider an alternative future or scenario where we can implement a group of nationally appropriate mitigation actions to be implemented. Now the UN FCCC uses the term with new measures scenario, and that is a group of actions that are anything from implementing new regulations, the use of market-based instruments, so carbon taxes or carbon trading systems. We could be providing subsidies to renewable sectors or high energy efficiency sectors. It could include voluntary initiatives that involve awareness or capacity building. So all of these actions would be implemented at different times from 2010 to 2030. And the cumulative effect here is shown by the blue line, the with new measures scenario. And with that, the with new measures scenario shown here shows that we can hit the 2020 emissions target, but yet we don't have enough actions to hit the 2030 emissions target. So this leaves an emissions gap where more actions are required to achieve the 2030 target. So in this case, it may be appropriate for a country to consider an additional measure scenario that considers additional actions that can help them achieve that target. I want to now conduct a second poll to see how aware participants are of whether their country has set targets and what those targets might be. So you should see a poll appear on your screen, and you can select whether your country has targets and whether you know what they are. What we do see is that we have a sort of a significant margin that where the country has set targets, but we also have a group representing countries that have not set targets, and then we have some people as well that aren't sure, or there are also representatives of countries that where targets are not applicable. So I'm now going to, in this next part of the webinar presentation, I'm going to walk through 3 of the main steps to developing emissions baseline projection in more detail. The first step is to develop a database of historic emissions. Now, data on historic emissions are required to be able to identify the trends of different economic and land use activities over time, and to understand how sources of emissions have been impacted by different policies and changes to the economy. In many cases, we're going to have greenhouse gas inventories available. So primarily, especially for Annex 1 countries, these are published now on an annual basis. But for non-Annex 1 countries, there's often a considerable gap in the presentation of emission inventories, and it may be necessary to conduct independent estimates of emissions, or at least collaborate with those responsible in government for preparing these emission inventories to get the data that we need. Now, it makes sense to gather as much historic data for the most recent period possible. The basic data that's required goes beyond just the level of emissions of specific sources. We also need to understand the relationship of these emission sources to different human activities. So here we have an equation, and at its most simple level, greenhouse gas inventory methods estimate emissions by multiplying some activity data by an emission factor. So an example would be, any type of fuel combustion from sources of greenhouse gas emissions, so from transportation vehicles to power plants that are fossil fuel fired. And the activity data in this case is just the quantity of that fuel that's consumed or combusted, and the emission factor that's relevant, which is simply an emissions per unit of the fuel consumed. Projections of emissions are dependent on changes in activity data, as well as potential changes in emission factors and parameters. So the International Panel on Climate Change has detailed guidelines, for the preparation of emission inventories, and they identify best practices for determining these emission factors and collecting this activity data. So that's all very well documented. When we go to develop bottom-up projections, we can do this, either simply in spreadsheet models. There's available IPCC software that we can use, and there are also other more complex accounting models that can help us to do this. LEAP is an example of one of those tools that's free for use for developing countries. The choice of modeling tool to prepare baseline and policy projections tends to be driven by a trade-off between the sophistication and accuracy of the results required and the resources that are available. Countries may choose tools based on what they are already using for planning and policy development, as developing any new models can be very resource intensive. Many developing countries have limited capacity and to use any of these tools, and that we can see listed in the table above in the examples column. In general, the models are categorized as bottom-up or top-down or hybrid, and the top-down models focus on economic interlinkages, while your bottom-up models involve developing a detailed profile of specific end uses and technologies that consume fuels and produce greenhouse gas emissions. I don't want to get into more detail here because it's pretty complicated, but to be clear, the most robust models are going to be hybrid models that use both types of approaches, both the top-down and bottom-up approaches. Now, what we want the models to consider is how emissions are likely to change given key transitions in the country. And these transitions include things like macroeconomic and demographic trends, structural shifts in the economy, projections of the main greenhouse gas emitting activities and sinks. We have an evolution of different low carbon technologies and practices, and the adoption of energy efficient technologies. And again, the idea is that to generate a business as usual scenario, it may not be advisable to use aspirational targets for economic growth, as these kind of, the sort of where we want to be may not be suitable as a business as usual counterfactual to compare our performance of mitigation actions. So I'm going to thank everyone for listening to the first part of our webinar presentation, and I'm going to pass the mic now to Melissa so that she can introduce the next presentation.
Great, thank you very much, Seaton, for that. In our second presentation, Seaton and Marie-Claude Bourget will present practical lessons that they have learned from conducting baseline emission projections in Kenya, Rwanda, and the Democratic Republic of the Congo. Now, you've been introduced to Seaton, but I'll just tell you a bit about Marie-Claude. Marie-Claude is currently working as a climate change and finance consultant for Eco Resources Incorporated, a Montreal-based consulting company. Her work primarily focuses on NAMA and climate finance capacity building projects. Marie-Claude also supports the Congo Basin country negotiators during the UNFCCC climate change negotiations. She's been involved in the carbon market for many years. Most of her career involved the private sector and the development of CDM projects in Africa. In this context, she worked on the validation and the implementation of afforestation, rural electrification, and alternative energy projects. So I'll pass it back over to Seaton to start on the second presentation.
Thank you, Melissa. There are a couple key things that we learned when we developed an emissions baseline projection for Kenya's National Climate Change Action Plan. What we found, it was very difficult to agree on a business as usual scenario. Policymakers in Kenya had different targets that they wanted to promote and they want to model. And so the policymakers in Kenya were interested in aligning the business as usual scenario with the Vision Kenya 2020 plan that they had produced. And that plan essentially outlines national targets and goals that they want to meet by 2020. The basic problem with that was that the targets in the Kenya 2020 plan include assumptions about climate financing and funding that normally we wouldn't want to include in a reference scenario, essentially because these are actions that may be taken that we don't want to include in the baseline. So we had to discuss at length with them what was appropriate for a business as usual scenario. Another thing was that although existing planning models had been developed in Kenya, and these models have the capacity to estimate emissions, it would have taken considerable resources to generate a robust emissions baseline projection that was linked to the existing inventory efforts as well. And basically because of the given limited resources of the project, it was easier in the end to conduct a more simple bottom-up analysis with inventory data than to try to update the existing planning models within country with the new information that they would need. And that was unfortunate because it meant that Kenya's planning group didn't develop the capacity to develop these emission baseline projections to a full extent, and that should have been the ultimate objective. So in the next slide here we see an emissions baseline projection for Kenya that we developed. In this baseline scenario, overall emissions are expected to grow about 3% per year from 2010 to 2030. Energy emissions and we can see the different wedges so we can look at the effect of each of these sectors on the increase in emissions. Energy emissions from transport, electricity supply, and energy demand sectors were projected to have the highest growth rate. and essentially we have a tripling of these emissions between 2010 and 2030. Overall, the growth is considerably smaller because emissions were actually declining in some of the other sectors. This baseline scenario assumed that the overall economic GDP growth rate was equivalent to 6% per year. That is actually not consistent with developmental goals, but we felt that it represented a reasonable business as usual baseline for this case. So I'm now going to turn the presentation over to Mary Claude to present some lessons learned in Rwanda and the Democratic Republic of Congo. Mary Claude, are you ready?
Yes, thank you. Thank you, Stephen. So I will take over from here. Well, I want to say hi to everybody attending this session. Thank you for joining us. So basically, what we did is that we took the methodology and the approach that Stephen explained, and we went to do an in-country data collection, both in Rwanda and in the DRC. So I want to present to you the lesson we learned in doing the data collection. So the points that I'm going to make apply for most of the least developed countries in collecting the data, although there are some country differences. For example, in Rwanda, we realized that the capacities were much stronger to collect data, and there's more capacities to do statistical analysis. So therefore, I don't want to say the data was more reliable, but let's just say it was more complete, so we could use more of the data. And also, consequently, Rwandans were more interested in the know-how to use the data rather than just the results. In any case, most of the points that I'm going to bring are applied to both countries. So obviously, it is difficult to find the information that we need. It is pretty complex to build these models and have all the data that we need to have accurate results. So some of the information is quite hard to find. A lot of the data is not centralized nor digitized. So when you do a desktop analysis, it's really important to know that you might not find everything you need. So an in-country visit is required. You can't really do this analysis without an in-country visit. So you have to account for costs and logistics and everything, the time that it takes to go in the country to get the data directly at the source. Now, we also realize that the official data is not sufficient. You really have to go, like Seaton was explaining, the best approach is a hybrid approach. So you really have to also go a bottom-up approach to get the data. So ideally you engage with the private sector. Private sector often gather information for their own use, and they're quite open to share the data. So using the private sector data is quite useful. We also go see development agencies or NGOs, and we combine that data with the official data we get from the public sector. Now, it's also interesting to see the discrepancies from different sources, and that also is a good indicator of the accuracy of the data. So it's important to go from many sources to know if your data is accurate or not. And like I mentioned, the institutional capacity is quite important to get the data you need. So I don't know if I have controls of my slides yet, but maybe Seaton, can you switch slides? Okay, thank you. So with this in mind, it's crucial to validate the data. You have to not only go get the data on site, but once you analyze it and structure it, you have to see local experts and validate your findings. Validation can be done and must be done actually through local experts, but also through international experts. So, because many reports are produced by international consultants, so they've collected the data. You don't have to redo the work they've done, and often you can have access to this data. So it's also interesting to look at other international experts and what they've done and use the data as well. Now, after the validation, like Seaton was mentioning, there's a basis of assumption that you need to use to build these projections in time. And The assumptions are as important as the data you collect, because a little error in the assumption can mean a very different slope in your projection. So the assumptions also have to be validated by local experts and or international consultants, but normally local experts have a better understanding of the growth of the economy and all these indicators that you use to build these assumptions. Also, when there's a lot of discrepancies in the data, what you could use is either an average. If the uncertainties are quite high, the discrepancies are high, you can do an average in the figures. And if the discrepancies are low, what we normally do is we use the lowest figure. That way we know it's more reliable or more conservative to use the lowest figure. To give you an example of the problem that you can find in interpreting the data, if you've attended the last two webinars, you're quite familiar with this example that I really like, but it's quite indicative of how using the data and interpreting the data could be quite significant if you don't use the right assumptions. For example, in the DRC, in rural areas, diesel consumption is automatically factored as a transport emission. When people go to the pump to get diesel, it is factored in the inventory as a transport emission. While in reality, 97% of the Congolese that use electricity are auto producers. So they go to the pump to get diesel to put in their generators. So therefore, the emissions are really should really be factored in energy rather than transport. So when you look at mitigations actions that could have an impact, it's more pertinent to use in NAMA in the energy sector rather than in transport factor, although the data would suggest the opposite. So the strategy that we built to acquire the realistic data is the desktop review, although challenging, is very important to set the pace and to really give you a good direction on where to go once you're in country. And I want to also, maybe I didn't emphasize enough, that when you're in country, it's crucial to have really good local partners, because you can't really necessarily go to public institution and automatically get the data. You really need to have local partners who know what door to knock on to get the data. So that's why it's important to meet with different experts, different stakeholders to really get a wide range of data. And another point that I found interesting is that when you see a gap in the data, you can compare with similar countries. I mean, there are cultural differences that suggest that behaviors and consumption might be different from a country to the next, but often you can find similarities that you can use data or assumptions that are used in another country and use them for a similar country. Another point that we found is that there are bigger gaps in the disaggregated data. As example, if you want to look at emission in transport and you need to know what kind of vehicles are used in the years and this and that, this information is almost impossible to get. The system for car registration is very weak in many countries. So this data would be based on extrapolation and assumption, while aggregated data like production of electricity is easier to obtain and by definition is way more accurate. So you have to be careful of what kind of data you use. So the next point, to straighten the analysis, focus on uncertain data that has a significant impact. So because it is costly and time consuming to get the data, it's important to really focus on what really matters. So there are, for instance, data that don't really have a significant impact on either the baseline or the projection. For example, maybe in the transport sector, you can spend a lot of money and energy to find all this information on different types of cars and years, but will it really make a difference? As opposed to if you spend that money and energy on collecting data in the agriculture sector, then the result is way more impactful and more meaningful. The other thing that we realize is especially when looking at NAMA and mitigation action analysis, it's really important to go see the private sector and especially the technology providers, because often they have done the analysis, they're familiar with the technology, the feasibility, if it's possible to finance certain projects, so you can really incorporate that in your projections. Okay, so let's do a poll here. What do you think is the fastest growing emission sector in your country? Okay, so the fastest growing emission, the transport and the energy demand seem to be quite the fastest growing. I mean, in developing countries, usually agriculture is the main emission sector, but in terms of growth, I would agree with you that transport and energy demand are growing. Seaton, you might want to add something to this.
Yeah, no, I guess there is a category missing here, which is industrial processes, which could, cement production and things like that, which could be significant. But this seems to align completely with what is generally we found in different emission baseline projections, particularly in the developing world.
Okay, so back to you, Melissa.
Great, thanks, and sincere thanks to our speakers. We will now take questions from the audience, and I invite Seaton to chair this part of the webinar. Seaton, can I hand it over to you?
Sure, that's great. If you haven't already, you can type your questions into the panel, and we can share them. And what I think we're going to try to do is, I believe we can put up some of the questions that people have asked. So let's start with question 1. Someone has asked, is there ideal institutional arrangements for systematic elaboration of a greenhouse gas inventory? That's a good question. I think there's still some work in many countries on what institutional arrangements they want to use to do this work. I would suggest that in most cases there's a ministry, a level of government that's responsible for the production of emission inventories. Attached to that ministry, there's likely also a group responsible for national projections. And getting these, they may be two different groups, and getting them to work together, use similar models, and communicate is a key problem, and I think we see many sort of countries dealing and coping with that. I can't think offhand whether I know that there's good guidance out there that someone's published that would talk about institutional arrangement. I think the U.S. Environmental Protection Agency has some guidance on institutional structure that could be helpful in this case. Mary Claude, do you have anything you know of that could help here?
No, I wouldn't have anything to add on this one.
Great. Let's jump to the next questions. So someone has asked, in practical terms, provided all national emissions info is available, what model does a country need to calculate a baseline? This is simply the question of resources. Resources, manpower, and expertise that's embedded in the group that's taking on this project. So the more, essentially the more resources, the more money, the more labor, the more expertise available, and also the more warranted. So, if we talk about Annex 1 countries and developed countries, they're putting a considerable effort and expertise into these projections, and they're using sophisticated hybrid models or multiple models that we had listed in earlier in the webinar in that table. There was an example column that listed all kinds of models, and if you go online to our course, there's actual links to those models, and you can see and learn more about them. I think the question might be more directed at developing countries and their challenge, because it is a big challenge on where do they go and what model do they select. As much as possible, it would be good if it was integrated already, if there was modeling that was done already in certain planning ministries, to be able to use those models at least to feed data and provide input to a series of new models. But if I had to sort of say there's limited capacity. The LEAP model, which is a model that has been developed specifically to aid developing countries in this kind of project, would be a good selection because it's free to operate, it's fairly intuitive, and it really can reduce the amount of labor because there's a lot of default inputs available from that model. There are other ones out there, so I don't want to promote just one, but I think that's how I would answer the question. Sorry, go ahead.
I just want to add something, and maybe it's more relevant to the first question, but it also applies to the second. I find that, I mean, every country has to provide a national communication, and with the new negotiation now, it's more often with every 4 years and a report every 2 years. So there is there are institutional arrangements to do these inventories in every country, and normally they use the IPCC standards. So I don't know if that answers
it. That's completely true, Mary-Claude, and the issue becomes when you do emission baseline projections, the guidance is much more limited. There's a lot of flexibility for any country, including developing countries, on what models they want to use. They have, they don't really recommend the models. They say, this is what we're looking for, this is what we want you to consider, we want sensitivity analysis, we want different scenarios and how you should build them. But in terms of identifying models, it's more up to countries to pick something that fits. I'm going to jump to the third question. So how difficult, time-intensive is it to calculate a baseline? And this is related before, it's a resource question. So it's something that could be done by a few people in a few months using basic models. Or it could be something that has an ongoing large group of people working on it continually and dedicated to produce. So it's sort of very, very variable. Mary-Claude, do you have anything to add on that?
No, I agree with you.
The fourth question, what an emission factor is and how it is to be calculated. There is, I recommend the person who asked this question to go into our online course, and there's much more detailed information on this. But an emission factor is something that has been determined through some measurement and testing. So, for example, the amount of CO2 that is produced when we burn a liter of diesel fuel. People have tested and measured that, and diesel fuel is not that variable. So there's a very narrow range from those tests of results that indicates what that can give us an emission factor. And so all emission factors are kind of developed in a similar testing way, and we can have emission factors for emissions from putting fertilizers onto crops, or from emissions from cutting down forests. There's all kinds of different emission factors that are developed. The question number 5 is, you suggest the use of hybrid models, but in your table you mentioned they are difficult to maintain and calibrate, and that they are resource intensive. For non-Annex 1 country, developing country, what would be an alternative? I think the answer there is that, I've sort of went over it already, and that for a developing country that doesn't have a lot of resources, they're going to have to find a happy medium. And I think hybrid models are simply too complicated to maintain. You're going to need different experts, economists, and greenhouse gas inventory specialists, and all these people have to work together to be able to run these models appropriately and provide the input information that's available. So I think you need, the suggestion would be, if there's limited resources, to consider models like LEAP that I've mentioned earlier that have a lot of supporting information. It's kind of a first level introduction to help countries produce these emission baseline estimates.
I just want to add just one quick thing is that I want to emphasize that even if you can't use a hybrid model, the key here is to really validate the data. So even if the data comes from top down, at the end of the day, the very least you can do is validate the findings with local experts on the ground, or even local stakeholders from various sources.
Absolutely. Number 6 question, a long-standing issue has been what to include and what to leave out in a baseline scenario. For instance, if the country already has some target for renewable energy for 2018, do you include that in the baseline or is it left out? That's a very good question. It depends very much on the structure of that renewable initiative. If there has, if the government has put aside the right financing and the financing has been secured and it's something that's happened before the start of the emission baseline forecast, the forecast period, then I would say you would include it. It would be then an existing policy, something that we expect to be put in place and will be done. How much that initiative delivers, we probably would have at that point enough detail to say, in the case, let's say it was wind power farms, how much power is going to be produced online and what the effect of that would be. And so the emission reduction expected from that initiative should be very clear and defined, and that way we could include it in the baseline. Now, if it was something, if it's a target, but yet there isn't financing available and no one knows exactly how big that initiative is going to be, and there's not a clear commitment that we know government will deliver upon, then it would seem to me better not to include it in the baseline. You may include, if there's been a trend in the historic past that, by their own initiative, let's say electricity utilities are bringing online different wind farms and they've demonstrated financing for these type of projects, then potentially some of that would be included. So unless, Mary-Claude, you have anything else to add, I'm going to jump to question 7. And here we have, go ahead.
No, I was just about to say you're the expert on that, so.
If after several consultations you still have discrepancies in data, what type of criteria could be used to choose which numbers to use in the baseline scenario? I think I'm going to ask Mary-Claude to address this one. She's kind of talked about it a bit already, so maybe you can clarify.
Well, as I was mentioning, with our experience and using discrepancies is when the discrepancies were high, you use an average, and if they're low, you use the most conservative numbers. If you still have discrepancies, it's a very good question, and I think you just vary your sources of where to get that data. I don't know if there's a criteria you could use. You can compare with other countries as well. If you have a similar country and your results are completely different, then you can assume that there's an error in either the interpretation or the data itself. So I mean, it's a vague answer, but those are the points I have for that question.
Great. Let's jump to question 8. What's the meaning of the marginal abatement costs? Is that the annual costs divided by the CO2 reduction emissions? In a way it is, but when we talk about marginal, so if we think about abatement costs, that would be, we could take the total costs, whether they're annual or not, and divide them by the emission reductions they deliver. And that would be, your abatement costs. And we might have to, consider what year the investment is made and et cetera. But when we talk about marginal abatement costs, what we're interested in is the costs for the next emission reduction. So let's say we have a whole group of projects in renewable energy that we're implementing, and they all have different abatement costs. Each additional project has a different abatement cost. If we wanted to build a marginal abatement cost curve, we would show all of those projects on one curve, and we would show it from the lowest cost the lowest cost project to the highest cost project. And so we could find the marginal abatement curve at any, the marginal cost is how far you've gone. Where are you in terms of implementation? What is the next project going to cost? So I hope that was clear. Is it possible?
And I think we have time for one more question after that, okay?
Okay, great.
Thanks.
So maybe I'll just add a very quick thing on the marginal abatement cost curve. It's difficult to explain without the graphic, but essentially it just shows you the cost, how much does it cost to reduce per ton. So it shows you where the cheap tons to reduce are essentially.
And we'll take one more question, and then we may have to end the webinar. Is it possible to get financing to develop the projection baselines in a country in South America? Yes, there are financing mechanisms for this type of thing, emission projection baselines, similarly as there are for emission inventory work. Mary-Claude, do you have more on that, the mechanisms that are available?
Yeah, I can't really say exactly with details, but there's definitely development agencies that are funding that type of work. So there are examples where countries got funding to develop projection baseline. And also we didn't really mention it, but the standardized baseline is also something that countries are looking into and helping developing countries establish their standardized baseline as well.
Okay, so Melissa, are we almost out of time, I think? Or do we have time for one more question?
Yeah, you've got one more really quickly, yes. Go ahead.
Okay, I'll try to keep it short. So the 10th question here is, which data is usually used in the Western world, example in terms of economic growth rates? So every country will have its own forecasting group or planning group, and they'll generate short-term economic forecasts. So they'll probably generate at least a few years, 5 years in the future. Some countries will develop these long-term economic growth projections as well. And so especially for Annex 1 countries, a lot of resources are put towards this kind of thing because it's very important, not just for emission forecasting and emission projections, but it's very important for national projections. I don't think anyone, even in the developing world, doesn't have some capacity here in some forecasts that they have available. So usually, let's say we're talking in the developing world, a ministry responsible for planning or finance ministry would have economic projections. And generally what we do is when we go to look for this type of information, we go to the ministry that has sort of the most weight and responsibility to develop these projections, and we ask them directly. It's like, what do you think will happen? Can you provide us those rates? And then we develop the forecast from exactly what they provide to us. So I think we're very close to being out of time, so we're not going to take any more questions. Melissa, do you want to wrap everything else up?
Great, thanks very much. So unfortunately we are out of time, but any of the unanswered questions have been recorded and they will be answered, and the answers will be posted on our online course. So I'd like to thank our speakers, our technical experts Pauline Gerard and Leslie Paz, and as well the audience, you, for your participation. If you'd like to register for our online NAMA courses or access the webinars, the link will appear on the screen here, or you can also email me, mharris@iisd.ca for more information. So with that, we will conclude the webinar, and thanks again for your participation.